we are looking for the heat release when 2 moles of steam at 150 degrees Celsius is transformed to ice at minus 30 degrees Celsius. We have a several step problem. First we have the cooling of the steam down to 100 degrees. Then we have the conversion of steam into water. Then we have cooling of water down to 0 degrees Celsius. Then we freeze the water, and then we cool the ice down to minus 30 degrees. So this is a 5-step process. Each time we have a single phase, we're using the specific heat equation, Q equals Sm delta T. When we are condensing the steam, we're using Q equals moles times the heat of vaporization. And when we're freezing the water into ice, we're using Q equals N times the heat of fusion. We have to have the specific heat of steam, water, and ice. If we aren't given them, we look them up. We're supposed to memorize the specific heat of water, 4.184 joules per gram degree Celsius. We need the heat of vaporization and heat of fusion. And if we don't have that, we look them up. We're going to need a mass for the specific heat equation. So we take our 2 moles, we multiply it by the molar mass of water, and we get that we have 36 grams of water. Now that we have all the parts, we put them into the equations. For cooling the steam, we use the specific heat of steam, 1.84, mass 36 grams, and the change in temperature is from 150 down to 100 degrees, the normal boiling point of water. So we have a 50-degree change, and we get that that releases 3312 joules of heat. To condense the steam into water, we have 2 moles times the heat of vaporization, 40.7 kilojoules per mole. That releases 81.4 kilojoules. To cool the water, we're cooling from 100 degrees Celsius down to 0 degrees Celsius, a change of 100 degrees. This is releasing 15,062 joules. To freeze the water, the heat of fusion times the 2 moles will give us 12.04 kilojoules. And to cool the ice, we're going from 0 degrees Celsius down to minus 30, a 30-degree change. This gives us 2,257 joules. The heat of the overall process is the sum of these, but we see that we have both joules and kilojoules, so we have to convert all into one unit. So I will convert into kilojoules. So we have the heat of the 5 steps in terms of kilojoules. Now we just add them up. 3.3 plus 81.4 plus 15.1 plus 12.0 plus 2.3. This adds up to 114.1 kilojoules.